Welcome to the presentation of our paper Extractive Summarization of Personal Photos from Life Events. People shoot and share lots of photos which capture their life events. However, to get an overview of the photo collection, one has to manually browse through it, a very tedious and inefficient process. We present a framework for automatic generation of size-constrained photo summaries that are good representatives of the larger corpus. We define a photo summary as a subset of the photos shot in a life event like a birthday party, trip, etc. Not all such subsets are effective summaries. The goal is to define properties which generate a desirable summary. We identify these properties as relevance, diversity, and coverage. Relevance determines how attractive the photo summary is. Diversity is a measure of non-redundancy. Coverage determines if the summary is a good representative of the large number of photos shot in the live event. The automatic summarization system is shown here. We extract multimodal features from photos that include pixels, time, EXIF, GPS, and text. We also derive 5 different semantic concepts from this data. These are face tags or people names, location names, event type, visual concepts, and temporal concepts. This heterogeneous data and concepts are used in the automatic summarization process. Relevance is a measure of attractiveness of a photo summary. It is defined as the aggregate interest values of the photos present in the summary. Interest of a photo determines its appeal to the user. As an example of photo appeal, let us look at the two sets of photos shown on the left and right. People like color photos. However, they tend to like photos with few distinct colors rather than lots of colors garbled together. As shown in the histogram on the right, the set of photos on the left have only few distinct colors, while the set of photos on the right have many colors jumbled together. People seem to like the previous set of photos. People seem to like high contrast photos as shown on the right rather than low contrast photos as shown on the left. Based on these intuitions, we define binary attributes which reflect the presence or absence of various appealing attributes in a photo. Interest of a photo is defined as a weighted combination of these binary attributes. Relevance of a photo summary can be computed by aggregating the interest values of the photos present in it. Diversity is a measure of non-redundancy. A summary should have minimal duplicate information. We compute distance between pairs of photos and aggregate them to generate a diversity of the photo summary. The distance can be computed in multiple feature spaces as well as in the semantic concept space. The final property is coverage, which determines the photos in the larger corpus which have been shot during a live event that are represented by photos present in the photo summary. Consider the photo on the left. It shows user Joe in an outdoor group photo shot in San Diego. This photo was included in the summary. Coverage determines the degree by which this photo represents other photos which were not included in the summary. For instance, how much does this photo represent a photo of Joe shot during sunset in La Jolla? Having defined these properties, we formulate summarization as a multi-objective optimization problem. Note that optimization of diversity and coverage are NP-hard problems. However, they have a submodular structures. Hence, greedy optimization has constant lower bounds compared to the optimal. We propose a greedy weighted aggregation method to generate an automated summary. For details, please see the paper. Evaluation of personal photo summaries is difficult as manual evaluation may be subjective and only contributors can evaluate summaries. Further, there are no standardized metrics to compare two different photo summaries of the same event. We create two ground truth photo summaries of each live event by asking the contributors to create ground truth at an interval of 5 weeks. We find that there exists only 40% mean overlap between two summaries of the same life event created by the same contributor at two different times. Hence, instead of evaluating summaries by comparing the raw photos themselves, we compare locations and people present in automated and ground truth photo summaries. Jensen-Shannon divergence is used to measure the distance between two photo summaries. We find that the greedy summary is least distant from the ground truth. We also define a recall-based metric, nugget gain, to compare the important concept present in two photo summaries. Greedy summary performs better for this metric too. For details, please see the paper. We also use nugget gain to compare summaries at different sizes with the original corpus. Here also, greedy weighted aggregation performs well. We also ask users to rank summaries manually. Contributors are shown a set of photo summaries of the same life event in an anonymized order. They are asked to assign scores to each of these summaries. Users were also asked to judge summaries based on specific questions from a questionnaire. For manual evaluation too, greedy summarization performs better compared to other automated summaries more often. For details, please refer to the paper. Thus, in conclusion, we find relevance, diversity, and coverage are reasonable properties to generate an effective photo summary of a live event. The greedy summarization process performs well both in manual evaluation and the information theoretic evaluation paradigm. With the popularity of smartphones that have many sensors on them, more semantic information may be available that will make the summarization process even better.